Alright, so for the next part of our notes, we're going to be going over conjugates. Example 5 and 4 accidentally got switched in the formatting, so we're going to skip that one and then come back to it in just a moment. So I briefly mentioned conjugates at the very end of the last video, saying that we're going to learn about them next lesson. Well, here they are. So if we look, conjugates, we have an a root b plus c root d and an a root b minus c root d. Well, these are conjugates of each other. They look the same, but they have those opposite signs. So these will always be opposites of each other here. So what we're going to do, we use these to help get rid of those radicals in the bottom of our fractions here. So if we look at example 4, we have that 1 over 5 plus the square root of 3. Well, its conjugate, I'm going to write that over here, conjugate, that's going to be that same 5 in the root 3, but instead of a plus sign, we'll have a minus sign in the middle. So what we're going to do here is I'm going to multiply by 1, but we're going to have it written in a different way, kind of like we had up above. So last time we had said, well, I need a 5 root 8, and we had gone through and we had multiplied to get rid of that using a 1 that didn't look like a 1. We'll do the same thing here. We'll have a 5 minus a root 3 and a 5 minus a root 3, because anything divided by itself is still 1. When we do this, that's that rule we learned that was an a plus b times an a minus b is equal to an a squared plus b squared. Well, our a in this case is 5, and our b is the square root of 3. So when I square those, well, if I square this one, we get 25. If I square this one, we just get 3 back out. So on the top, we'll have our 5 minus the square root of 3 divided by our a squared, here, 25, and minus our 3 here. So last simplifying step, we have 5 minus root 3 divided by 25 minus 3, or 22. So our conjugates are what help us simplify these when we have radicals on the bottom and there's something being added here. If you look up above, remember, it's just that opposite sign that we're dealing with. So, like I said, we're going to come back to example 5, adding and subtracting like radicals and roots. This is a little different from our conjugates, so hard transition here. Adding and subtracting them. It works similar to a variable. We say, okay, if these are the same, then we can add these together. I'm going to look at those coefficients in order to do it. This is an invisible 1 here. So we have a 1 plus 7, well, that's an 8, and then we just carry that 4 root 10 down. Over here we have our b. Well, on the inside, they're both to the 1/5 here. They're both an 8 base, so okay, we can add those coefficients together again. 12, and then we have an 8 to the 1/5 power. So just like we do with our variables, all we change is those coefficients. Now for c, they're both third roots, but what's underneath looks different. We have one that's a root 2 and one that's a root 54. But if I'm looking at this, 54 can be divided by 2. 54 divided by 2 is going to make this the cubic root of a 27, and the cubic root of 2 minus the cubic root of 2. So we just brought this part down and we split that 54 up. I then use the product rule in order to break those into 2 separate radicals. Okay, so here, then we have a 3, our 3 root 2, and minus 3 root 2. So now these look the same. We have our 2, and they're both to the third. So now I have 3 minus that imaginary 1 when there's nothing in front. So we have 2, and then the cubic root of 2 here. So these come in later on once we've done some of our conjugates and have to add and subtract. But overall, it's pretty simple. It works just like our variables. We make sure they look the same and add or subtract those coefficients. Okay. Next part, if you look at your notes, it says, because a variable can be positive, negative, or 0, the absolute value needs to be used when simplifying a variable expression. And that's because of some of our things that end up being undefined if it's negative. So this was supposed to be on the next page. So flip your pages over. This is the information it goes with. Our rules here are that when n is even, we need that absolute value. And that's because if I have the square root of x, but x is less than 0, there's technically no solution because we get imaginary numbers. But when it's odd, we will always have one solution and it will always be real, so we don't need our absolute values. So if we look at example 6, simplifying a variable expression now, so now instead of numbers, we're working with our variables again. We have the cubic root of a 64 and a y to the 6th. Well, what we can do here is we have the cubic root of a 64 times the cubic root of a y to the 6th. Well, what we're going to do here, cubic root of 64, that's just a 4. And then here, we can divide these. Well, 6 divided by 3 is an even 2, so we can say, well, this is also times a y squared. Over on part B, we have an x to the 4th divided by a y to the 8th, and we're doing the 4th root of each of these. So this is our quotient rule. I can split this up. I'll have the 4th root of x to the 4th divided by the 4th root of y to the 8th. Well, here they're both 4, so those are going to cancel. That's like what I talked about over here, because if I divided 4 by 4, we would just get x to the first power. So we have an x. And here this is an 8 over 4, so we have a y squared. That's just doing the reverse of writing this in radical form. Technically we're rewriting this as y to the 8 over 4, which gets us to that y squared. Now, sometimes there's a lot more going on in our radicals. We can have multiple variables here. So if we look at a, we have the 5th root of 4, a to the 8th, b to the 14th, and c to the 5th. Well, not all of these can be divided evenly by 5, so what we need to do is break them up. Right now we have the 5th root. I'm just going to say, okay, well, we have a 4. We could have an a to the 5th. If that's a to the 5th, we also have an a cubed. And that b to the 14th, well, I could make that 10 because that's divisible by 5 now. And then we have our b to the 4th and our c to the 5th still. So here, I can now take anything that's to the 5 or divisible by 5 and take those out in front. So this 4 here, nothing can change. But this a to the 5th, well, if I divide by 5, I get a to the first power. A cubed is stuck. Well, b10 divided by 5, though, that's an even 2, so we have a b squared, because 10 divided by 5 is 2. That one's stuck. C to the 5th, though, brings one c out. So now I write everything that was left behind. Okay, I left the 4 behind. I had used that. I left the a cubed behind. I used that. B to the 4th, and then we had used that. So the things I've circled here are the 3 that were left behind underneath our radical. And don't forget to carry that 5th root down. This is going to be our simplest form for this. For b, we have x divided by the cubic root of y to the 8th. Well, we can simplify that y to the 8th sum because I can pull out a y to the 6th here. So we'll do that first. So I have the cubic root, we have a y to the 6th, y squared, because 6 plus 2, that's 8 still. When I divide by 6 and 3, we'll end up taking a y squared out. And now we have the cubic root of y squared. Well, if I can get one more y in here, these can cancel out. So I'm going to multiply by the cubic root of y, because I have 2 and 1 that adds up to 3, which I need in order to cancel those out. But we always want to multiply by 1, so I'm dividing it by itself. So the last thing we'll end up with is x, the cubic root of y, divided by a y cubed, because I have an x squared here, and we'll get 1x out of, or 1y out of all of this. Okay, so 14 halves here. First thing I'm going to do is simplify that. I know that's a 7. Now we have that quotient rule where we subtract our exponent, so this is technically to the first power, so I have x, and that's to the 1 minus 3/4. I have my y to the 1/3, there's nothing else down below. Then we have that z, it's to the -6, which is a little weird because it's on the bottom and it has a negative exponent. Well, we can pretend there's a z to the 0 power up here. If I have 0 minus a -6, well, now my exponent is going to become positive. So the next time I rewrite this, we'll have 7 x to the 1/4, y to the 1/3, and z to the 6th. Last thing, we have a fraction here, and we have a fraction here, so what we want to do is simplify those into radicals. So here we'll have a 7, the 4th root of x, the cube root of y, and then we have our z to the 6th. Now, last example, example 8, adding and subtracting variable expressions. If we look at this first one, they're both the square root of y here, and they have a 5 and 6 on the outside, so since this is the same and this is the same, we can just add those coefficients. 11 square root of y. If we look over here at b though, well, they both have a cubic root, but what's on the inside is different. We have a 2z to the 5th and a 54z squared. So underneath this radicand, we have that 2z to the 5th, 54z squared. We need to change something. I'm going to leave this front one alone because it has a smaller 2 at first, but it has a larger exponent, so I'm going to split that up. Well, I can make that z into a cube and a z squared, because those add to 5. For my other one, I have a z on the outside, cubic root. Well, 54, we already talked about that earlier on. That can be split up into a 27 times 2, and then we'll have that z squared still. So what I can do here is I can simplify. I can take the z cubed out and I can take a 27 out. So now we have 12 times a z here, cubic root of a 2z squared, minus, well, when 27 comes out, the cubic root of 27 is a 3, so 3z, and then our cubic root of a 2z squared. Now they match. What I'm going to do now is add what I see in the front here. Well, I have 12z's and I have a minus 3z, so I'm going to subtract these two. 12 minus 3 is a 9, and they both have z, so z goes here. Our cubic root of a 2z squared. So there's a lot of steps here. The biggest thing is making sure you get that underneath the radical to match. Do not forget that. If they don't match, you can't add or subtract these from each other. So, if you haven't yet, you should be flipping the page over. There's practice on page 10 from the first part of 6.1. You need to complete that now if you haven't already. And then over here on page 11 is the rest of the practice for this lesson. So make sure you complete those as well.